Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another GameMaker tutorial. In this tutorial, we're going to be covering pathfinding inside of our random level generation series. So this is a series I'd done quite a while ago, but a lot of you have requested some extras. So I've been adding on those extras to the series. They weren't originally planned, but I think they're a good thing for this series. So real quick, I wanted to mention that my GameMaker book and my the PDF version of my GameMaker book and my GameMaker video course are both on sale right now for the Black Friday, or technically more appropriately named end of November sale, since it's clearly not Black Friday yet. But for my end of November sale, you can get them both for $10 on my website. They're $10 each. So go check that out if you want to. If you've been waiting, if you wanted to get those but you've been waiting for a while, now's your chance to grab them at a really cheap price. So let's get started. First thing we're going to do is run the game, and you'll see that we'd already added enemy. So we've added loading rooms, but we're not going to load a room right now. But we've added enemies get spawned in our room. So they get created, and we can move, through the room and find them, but they don't actually do anything. So what we need to do is we need to set up a grid that's for using GameMaker's built-in pathfinding functions. Now GameMaker uses the A* algorithm for its pathfinding functions. So we're going to set that up. So you're going to go into your level object, because we're going to you need to kind of build a grid of data that can be used for the pathfinding. Now, it might be possible to use this grid in some way or merge them into one grid. And that might be a good challenge for you if you want to try and figure out how to do that. But I'm just using two grids. It works fine. You only create it at the start of the game. It doesn't take up a lot of memory or anything. So I'm using two grids. So let's create the pathfinding grid. Create the pathfinding grid. Now there's a special way that you create a grid that will be used for GameMaker's pathfinding functions, and it's called MP grid create, I think. So we're going to name this grid path. Grid path equals MP grid create. Now we pass in specific values. So where do we want the grid to start? Well, we want the grid to start in the top left corner. So that would be 0, 0. How many horizontal cells are there? Well, technically we already have this up here, the width and height of our other grid. So we can just do width and height for the horizontal and vertical cells. What's the cell width? Well, we've stored that in a macro, cell width and cell height. Okay, and that should create the grid path. Also, just a quick thing to note, this tutorial is for more advanced users. So if you're a beginner to GameMaker, go check out my beginner RPG series, because that's great for just newcomers. I would not recommend watching this video if you're a brand new beginner. Plus, you need the source to this, so you need to have followed along the other videos. Okay, now that we've created the grid, what we need to do is actually tell GameMaker what cells inside of this grid should be solid objects, should not be able to move through. So if we go down, if we scroll down, scroll all the way down to here, okay, where we draw the level using the grid. Inside of here, we're stepping through our entire grid, okay, and we check to see if we're on a floor tile. Well, everything that's not a floor tile is going to be a solid object inside of our grid. So we're going to do else on the end of this if grid equals floor. And we're going to do MP grid add cell. And we can just do grid path, because that's the name of the grid we created. And we're going to do the horizontal value and the vertical value of this cell, which is just XX and YY. Those are the X and Y positions of the cell that we're going to add. So this should add a solid value to that cell. Really easy. Now what we need to do, and I don't remember if I did this in the other ones or not, but we need to make sure we destroy both of these grids in a room end event. So I'm going to add event, other room end, just to clean up the room so that we don't save them. Destroy. Wow. The grids. I can't type today. DS grid destroy grid. DS grid. No. MP grid destroy grid path. So this is a grid. We're destroying the grid for our room random level generation, or destroying the grid for our. And let me make sure Skype is closed. And we're destroying the grid for our pathfinding. Okay. We only create the pathfinding grid once. We create it in the level object, so there's only one of them. We don't need to create a grid inside of every single enemy object because they can all use the same grid. It's all the same room. And our room isn't changing, so we only have to do it once. If you were to change the layout of the room, like say you had destructible terrain, you would need to update the grid based on those changes. But you should just be able to go in and remove that specific cell instead of having to redo the entire grid. Okay. Now what we need to do is we need to start modifying our enemy object. So our enemy object needs to be a little bit smarter than it currently is. Inside of our create event, we're just going to name this initialize the enemy. And then we're going to create a path. So path equals path add. And I don't know why it's not path create, but path add is how you create a new path. And we're also going to add a step event. Step. And inside of this step event, we're going to update the enemy's depth. So update the depth. Depth equals -y. Okay. Now, we also need to destroy that path. So add an other event, a room end event. Destroy the path if path exists. Path destroy path destroy or delete path. Now why am I checking to see if the path exists? Because we're also going to add this into the destroy event for the enemy, just in case the enemy gets destroyed. You know, if the player kills the enemy before the room actually changes, we want to destroy the path there so we don't have to worry about it anymore. Okay. Now what we need to do is we need to write the code that is going to actually move the enemy around in the room and get to the player. So I'm going to use a script for this. And I'm going to name this get path to player. You know what we could do that might actually make this a little bit better? Yeah, we can just leave it this way. Get path to player. If you wanted, you could just call this get path to point and then have them pass in an X and Y value. That would be a good way to do this as well. But we'll just do this. It'd make it more usable for other scenarios. Okay, so first thing we're going to do is we need to get the player's position relative to the grid. So we're going to do var temporary x or tx and var ty for temporary x and temporary y. In fact, we could just use x, x, and xy and y, y. That's normally what I do. So we'll be consistent. It's going to be player.x div cell width. So what that's going to do is it's going to divide the player's x position by the cell width and return that value with no decimals. It will be a whole number. Then we're going to multiply that by the cell width. This is going to get us the top leftmost corner of the location of the player in the grid, basically. And then we're going to add the cell width divided by 2. And that's going to get the center of the tile that the player is on, basically. And we're going to do the same thing for our Y position. Only with our Y position, we need to change all these to height. And also the players, we're not looking for the X position, we're looking for the Y position now. And actually, before we do all this, just to make sure your player object is in the room, do if instance exists player first. Okay. Because sometimes you get errors if the player doesn't exist. Now we're going to do if mp grid path. So this function actually, it returns -1 if it can't find a path there, so then it won't move. That's why we're putting it inside of an if statement. But if it can find a path, then it returns 1. And it also changes, we pass in a path, and it also changes that path and updates it if this actually works. So this is actually creating the path that the enemy is going to use to get to the player. So we're going to pass in some information like level.grid path, which is the path or the grid that we're going to use. Then we're going to pass in the path that we're going to use, which is just path. We already created that. Then we're going to use our X start position is just our X position. Our Y start is going to be our Y position. Our X goal is going to be the player's X position, XX, and the Y goal is YY. Do we want to allow diagonals? Basically, do you want to let them move diagonally? We're going to say yes, so true. Then, if all of that works out, our path value is going to be updated. So we want to start moving on a path. So path, start, and we're going to use path as the path we're going to move on. The speed is going to be 2. The end action is going to be path end, or path action stop, because we want to stop when we reach the end of the path. And absolute, we want to set this to false. Yeah. Pretty sure. It might not matter, actually. I don't know. Because we're getting from the X and Y position of the enemy. Anyways, it works this way. So now that we've got that set up, we need to tell our enemy, the enemy actually needs to call that script. But we don't necessarily need to call it every single step. That would be a waste to do that. It would also be more taxing. So what we're going to do is we're going to call it every second. So inside of our create event, do alarm 0 equals room speed. So this will mean we set the alarm to 1 second. Okay? You can actually copy this. And then in the alarm, create alarm 0. We're going to move towards the player. We're going to call our script get path to player. And then we're also going to re-update the alarm again so it calls it again the next second. Okay? So every second it's going to re-find the player and move towards the player's position. Now we can actually run our game at this point and you'll see that things are working. No, we don't need to load a room. Enemies chasing me. Looks pretty good. Yeah, they're all coming along, following me along this path. If they reach me, they stop. And then the next second, they start following me again. But it all works. The only problem with this is you can see the enemies start to get stuck inside of each other a little bit. especially as we get close like this and then move away. All of a sudden, all the enemies are right inside of each other. So that's not good. We don't want them to be able to go inside of each other. So I wrote a script that kind of helps with this. For the enemies getting stuck inside of each other. And there may be a better way to do this. I didn't really get a good chance to stress test this. The basic pathfinding is in there. How you decide whether or not an enemy will move inside, like whether or not an enemy could get like that, moved inside of another enemy where they're gonna look like they're the same enemy. How you decided to handle that is kind of a separate video, but I did come up with a solution that works okay. So let's add an event. Let's add a collision with the enemy. And inside here, we're going to write just a little bit of code that should help with that issue. So first of all, we're going to try and move away from the other enemy. If we're on the exact same position though, we won't be able to use our distance to move away from each other, or the direction, because the direction will always be 0 if we're on the exact position. So we need to check for that. If x is equal to other.x and y is equal to other.y, okay, if we're in the exact same place, how do we differentiate between these two enemies? Well, we can use their ID. So we're going to move, and the x movement, or the horizontal speed, is going to be either -1 or 1. And we're going to determine that by doing sine other.id minus id. So we can use the enemy's own ID values to determine which one moves where. Okay? And then we're going to do 0. So that's if they're in the exact same spot. Every other time, we're going to do something different. We're going to do var dir equals point direction other.x, other.y, x, y. So we're pointing from the other enemy to us. That way when we move away from it. And then we're going to do var h speed equals length dir x. The length is going to be 1, and the direction is going to be direction that we just got. Var v speed, or v speed equals length dir y, 1 and dir. And then we're going to attempt to move. Now we're using the move script that we already have written because that will prevent the enemies from moving into a wall and then getting stuck in there, hopefully. That's the idea. Now, you can mess around with this value. I did 1. Maybe 0.5 works. I mean, it depends. You can just mess around with that to try and see what looks the best when they're stuck inside of each other like that, and see what works. So 0.5 actually seems like they can still kind of get stuck, but not all the way that when you stop they stay. So they still kind of move outside of each other. So 0.5 seems to work pretty good that way. They do kind of overlap a little bit when they're moving together like that. You can see them overlapping a little bit. If you want them to overlap less, you can put this to 1. But it also seems to make them jitter a little bit more. So they're a little bit more kind of jittery in their movement. So messing around with that value is something that you can mess with. Like I said, this tutorial isn't specifically about how you're going to handle their collisions with each other. It's more about how you're going to handle the pathfinding, which works perfectly. You can see I can come clear over here, clear around, and they were smart enough to not go the long way. They just cut back the way they saw me going. One of them got stuck going the long way, so this works really well. Anyways, hopefully you guys found this video useful, and I know a lot of you have really enjoyed this random level generation series, so that's why I've continued to make videos for it. I really appreciate you guys' support, and I will talk to you guys later.